In this video, we're going to learn how to solve a system of three equations. Now, you are more familiar with a system of two equations with two variables, for example, x and y. So every single time they give you a system of three equations, your first aim is to try to reduce these three equations into two equations with two variables. So let's go ahead and look at the first example we're going to be working on. Now, yes, they did give you three different equations, but the first one is basically just a mere value for y. So if you take this value and plug it in the second equation, you will see that you will only be left with a z. So let's go ahead and try that. So the first thing we're going to do is we're going to solve for a single variable from one equation, which is already done for us. Y is equal to 3. Now our second step is we're going to be substituting this value in the second equation. Now again, this is just specific to this example. So let's go ahead and plug in 3 in our second equation. So we end up having negative 3 plus 2z equals negative 13. Let's isolate the z by adding 3 to both sides. So 2z will be equal to negative 10. Divide both sides by 2 since we're solving for z. Z will end up being equal to negative 5. So now we have two variables. Now if you look at the last equation, which is 3x minus 2y plus 2z equals negative 10. Now I do know how much x is, or I don't. I don't know how much x is. I know though how much y is, and the z is equal to negative 5. So let's plug in the values. 3x minus 2, y is 3, plus 2 times negative 5 equals to negative 10. So as you can see, the only variable is x in this case. 3x minus 2 times 3 is a 6. 2 times negative 5 is a negative 10. Let's combine these two, and that's going to give me negative 16. Now let's isolate the x by adding 16 to both sides. So 3x is equal to negative or positive 6. Now divide both sides by 3. You're going to end up having x equals 2, since 6 divided by 3 is a 2. So in this case, my solution is going to be 2, which is x, 3, which is the y, and then negative 5, which is the z. And that's the solution of the three equations. So even though I have a system of three equations, it was easy to solve it. So every single time you have a system of three equations, try to reduce it into something that you're familiar with. Now let's look at this system of three equations with three variables, r, s, and t. Now the first thing we need to consider is eliminating one of the variables. So let's see which one is easy to eliminate. Is it s, is it r, or is it t? Now if I look at the t, this is a 40 over here. This is a negative 40 over here. So if I try to add the first and the third equation, the t's will cancel each other. So let me number them as 1, 2, and 3. And what I'm going to do is I'm going to try to add equation 1 and equation 3. So I'm going to write add equation 1 and equation 3. So let's go ahead and add them. Let me write them down so it would be easier for me to add. That's equation 1. And let's write equation 3 as well. Okay. Now if I add 4r minus 3r, that's going to give me an r. Negative 4s minus 3s, that's going to give me a negative 7s. Positive 4t and negative 4t will cancel each other, and negative 4 minus 16 will give me negative 20. So as you can see now, I have an equation of two variables, r and s. I have eliminated t. And that's going to be something familiar for me. I know how to solve an equation with two variables, but I need another equation. So I need somehow to eliminate t from another two equations. So for example, I took now 1 and 3, and I eliminated the t. Now I can take 1 and 2 and eliminate t as well, or I can take 2 and 3 and eliminate t. So remember, you have to always eliminate the same variable. If you have added 1 and 3, as you can see what we did over here, and we got rid of the t. Now let's go ahead and add another two equations and eliminate the t as well. So which one can I choose? I can choose 1 and 2. But this is 4t and this is negative 2t. So most likely I need to multiply the second equation by 2 to get this to be a negative 4t. Because then if I add them, they will cancel out. So let's start by multiplying. So 2 times equation 2. Okay? So I'm going to multiply equation 2 by 2. So 2, open parentheses, 4r plus s minus 2t equals 5. I need to multiply each part of this equation by 2. I will end up having 8r plus 2s minus 4t equals 10. Now I have an equation that has a negative 4 in it, and negative 4t. Now let me copy equation 100, because now what I'm going to do is I'm going to add 1 and the new equation 2. So this is the new equation 2, the one that I multiplied by 2. Okay? Now let's add these two together. So let me copy equation 1, 4r minus 4s plus 4t equals negative 4, and I'm going to copy the new equation 2, 8r plus 2s minus 4t equals 10. And I need to add these two together. So let's review what I did. I multiplied the second equation by 2, so I would end up having a negative 4 over here, because plus 4 minus 4 is equal to 0. So after I multiplied the second equation by 2, I'm adding it to equation 1. So let's do that. 4 plus 4r plus 8r is going to be 12r. Negative 4s plus 2s, that's going to be a negative 2s. Positive 4t, negative 4t, they cancel each other, and that's what I wanted. And negative 4 plus 10 is going to be equal to 6. So now I have a second equation with only two variables, which are r and s, exactly like this one, r and s. Now these two are equations I can work with. I learned how to solve a system of two equations in Algebra 1, either by substitution or by elimination. So let's copy these two equations down, and let's decide which one would be a good method to solve. Now, as you can see, I have a single variable, so probably substitution is the method that I need to choose. So I need to start by isolating r, so I'm going to add 7s to both sides. So r is equal negative 20 plus 7s. Now after you solve for the single variable, you plug it in the second equation. So 12 times negative 20 plus 7s. So you see what I did? I plugged this in here where r is. And negative 2 or minus 2s equals to 6. Now let's go ahead and distribute. 12 times negative 20 is negative 240 plus 12 times 7 is going to be 84s minus 2s is equal to 6. Now don't forget that you can combine like terms, so 84s minus 2s, that's going to be 82s. Now don't forget to add 240 to both sides. So 240 plus 6 is going to be 246. Now don't forget to isolate the s by dividing both sides by 82. So in this case, s is equal 246 divided by 82, which is 3. So s in this case is 3. Now once you find s, don't forget to plug it back in the previous equation where r equals negative 20 plus 7s. So r equals negative 20 plus 7 times 3. So r is equal negative 20 plus 21, which is equal to 1. So in this case, r is equal to 1, s is equal to 3. Now remember, but there's 3 variables. There's r, s, and t. So go back to any of the first equations. So let's say number 1, 4r minus 4s plus 4t equals negative 4. And let's plug in what we found r and s to be in order for us to find t. Now r is 1, so 4 times 1. S is 3, so negative 4 times 3 plus 4t equals negative 4. Now 4 times 1 is 4 minus 12 plus 4t equals negative 4. 4 minus 12, that's a negative 8, plus 4t equals negative 4. Add 8 to both sides. So 4t is equal to 4. Now you need to get t by itself, so you divide by 4. So t is equal to 1. So I just found all 3 variables, r, s, and t. So the final solution is going to be 1, which is r, 3, which is your s, and 1, which is your t, r, s, t, in order. And that's going to be the solution of the system. Now, if you would like to check if your work is correct, go ahead and plug in r in here, s in the second one, and t to be equal to 1. Do that for every single equation and check if you're going to get the numbers, the constants over here. If you do, so you basically just plug them in. And if you do get the same constants, then your solution is correct. And that's it for solving a system of 3 equations.